Here we are with our sixth example of volume of a solid of revolution. And once again, we've got the same two curves. This will be very similar to homework. Again, make sure you get these points of intersection right because you're going to use them on every one of them. And so x equals 18. I went ahead and put over here 18 on the x-axis, vertical line. We're taking this region and swinging it around this way. So we've got the original region, and then we've got its mirror image over here when it hits the board on the other side. And again, I'm perilously close to the edge, but you get the idea. So again, my thought would be to connect the two curves, pick a number between 4 and 9 and call it x. Hello, my name is x. I represent all numbers between 4 and 9. That value of x would create a vertical purple line between the two curves, swings around, hits the board again on the other side. Notice this time we're swinging it this way, and that impacts something. All right, and then we've got a cylinder. And every value of x would have a cylinder just like that one, and they're nested within, and they all have different radii and different heights, don't they? That's what these expressions are. They represent the different radii and heights. Now, I hope you'd agree that the radius, or pardon me, let me start over, the height, that purple line would still be upper minus lower. I think we can leave that on here. But what would be the radius? Remember, 2 pi rh. Let me bring it up. When you're going around a vertical line, think cylinders, 2 pi rh. Distance between the curves isn't going to change, but the radius expression. The radius would be this. And what you need to realize is that wouldn't 18 be bigger than every number between 4 and 9? So shouldn't the radius be 18 minus x? Boom. All right? So it all has to do with the relative positions of the two. If you're revolving around something that's above your region, to the right of, then it'll be at k minus x. All right? I don't have a double arrow here. I couldn't fit it in there. But yes, those could be switched depending upon their relative positions. So that would be the setup here. Make sure to put the dx on the end, please. All right? And then same speech. If you feel like doing the algebra here, combine like terms, distribute 2 terms, 3 terms, it's going to be a bunch of terms. It'll take you a while. It'll give you a good workout. Might I remind you again, that would be extra credit, so we don't owe it to you. But for 2 points, if you want to go do the arithmetic on that, and you already have the answer slide that was given, but just for the record, to finish it out, if you want that extra 2 points, that turns out to be 958.3 repeating. I want to remind you one more time, apparently the integral itself was half of this, and then half of this times the 2 made that, and then the pi, and units cubed, volume, there you go. So, I think that will take care of that. That should give you enough examples to help you successfully do assignment 30, 31, 32. And so, I think as we leave here, why don't we go ahead and pump up the volume on this one. I miss you guys. Get up and dance with me. Pump up the volume. I'm going to pump up the volume.